In this video, I want to show you a few quick tricks to understand the variables that you're messing with in Leetcode. So, for example, if we want to understand what root does, let's simply return root and understand how it looks conceptually. So, as you can see, assuming that we are given a test case of 1, null, 2, and 3 with the diagram shown here, we can see that returning root will show us that tree node of the first node, because root is looking at the very first node, will have val, left, and right parameters. And each parameter has its own uh, unique tree node or integer. In this case, we have left being none because there's no tree node here, and we have that right has its own tree node with a value of 2, and left of that tree node is another tree node with value 3 who has left of none and right of none. And then this right is referencing this tree node. So right of 2 is also none. And then left of the very first tree node is also none. So this gives you a very good conceptual understanding, and you can actually visualize it on how this binary tree is built. So we can continue and try to access these variables, which will be used in multiple data structure binary tree problems by accessing root.val, which we'll expect to return 1, because the val of the tree node that we're looking at is 1. And we'll see that 1 is not a valid value, which means that it's looking at 1. So if we want to access the value of this node, we have to think about it and see that this value is defined in the right parameter of the first node. So root.right.val will give us 2. And that's 2 right there. And then as we can expect, we can do root.right.left. Let's not even do val. Let's just see what happens. And we'll expect to have a tree node with value 3 that has left none and right none. Similarly, if we do root.right.left.val, we can expect to get 3. So this is super important because a lot of people, such as like my friends, will have like issues that they'll bring up to me, like, what's the difference between tree node and val? Which is a legitimate question from a beginner, because we think that a tree node is simply defined by the value that it has. But once you show someone this, they can understand that, for example, let's just do root dot right dot left again. We can see that the tree node is different from the val because a tree node has val, left, and right, as seen by this instantiation in the tree node class. However, val is different because it only looks at the value parameter and outputs that integer. So this is very, very helpful for a lot of people, and I hope it was helpful for you. And I'll link a video in the description once I finish on this problem in particular, dealing with recursion and iteration. And I wanted to emphasize and just like give you a sneak peek of that, especially with recursion. You can see that why recursion is so helpful in binary trees is because tree node is instantiated again and again every time a node is done. So there's a tree node within the tree node, and this tree node also has a tree node in the left parameter, which shows that we can access different tree nodes multiple times just with maybe 2 or 3 lines, because recursion repeats a method multiple times in order to get the value or get the return value we want. Hope you guys enjoyed the video. Hope you guys learned something. I'll be posting a lot more videos on binary trees in the near future, so like if you learned something, and subscribe. And let me know how your data structure journey is going. Hope to see you guys in the next video. Peace.